So with that, I'm going to introduce Deborah, who is going to do an update on the demand-driven operating model. This is a very, very interesting topic. As many of you know, we've brought our scheduling and execution solution into the, into the cloud now with Intuiflow. She's done with her husband, Greg, some really interesting projects that also include engineering phases of activity and things like that. Everybody knows Deborah, so come on up.
So today, let's see, in 2021, I think we gave you an update on what it looks like when you have quote to cash in an engineered order system. And Craig, you're here somewhere. You were part of that. And so was Nate with KES, which is Koch Engineered Solutions. So for the last 4 years, we've been working with them. You saw what Jay-Z did, which is John Zink Hamworthy. I'm going to show you Koch Glitch. We have a long history with using Concerto software. Started doing that back at Laterno Technologies. I think that was 2004. So give you an idea of where we're going now and some things that we've discovered. I was just at HydroRig, which is an NOV, and Texas Oil Tools, which are two new customers and plants of ours that we're going to get started on the next couple of weeks. They're going to follow the model I'm going to show you at the end. Okay, so I'm going to skip this. I'm going to do it really fast. This is how really old I am, okay? Very first book that this started is in 1995. In 1997, I wrote a book called Measurement Nightmare. All this was about the theory of constraints. In 95, I taught for 7 years at the University of Puget Sound and in the master's program at the University of Washington. Left a good paying job because I fell in love with a book called The Goal. If you haven't read it, you should. Couldn't do anything with it. Nobody really could. I knew Goldratt gave scholarships to professors. I couldn't get the Clorox company to send me. I came out of Deloitte. I was a director of finance for their second largest division. And the only way I was getting there was teaching. So I got a grant with a professor who's the most published professor in management accounting, a guy named Professor Eric Noreen, Dr. Noreen. I could have gotten a grant to nothing. The Institute of Management Accountants gave the second largest grant to it, and we studied the theory of constraints. And what we were looking for is people who said they were successful with TOC. Dr. Goldratt provided us with a list of customers in Europe. I did North America. Eric did Europe because he taught in France because he was a real professor. Long story short, Chad ended up going back to the Goldratt Institute after he graduated from college. That was my college gift to him. He wanted a car. He got that. Goldratt liked him and 7 other young people. So he chose them from 200 people from around the world who were children of associates of the Goldratt Institute. He came back and said, oh, wow, I'm going to work for this. And this is how we fell into TOC together. So in 1996, we started, 96 or 97, we started Constraints Management Group. What I want you to see is in 1998, we found Ditch Witch. It was one of our first big clients. We came out, we figured we had enough by the time I'd done a bunch of work in consulting for clients that were associated with the university. So that's how I got started in Seattle. Chad had put together quite a extensive work for 2 years with the Goldratt Institute. So we formed this, and what we found in 1998 was the power of decoupling, very deep bills, 14-layer bills. That's where replenishment was born. That's where DDMRP came from. There was no software, there was nothing to do. And by the time we got to 2001, 2003, we tackled the largest privately held forestry company in North America. I want you to look at those results. That's where this has all come from. What we learned there was the power of vertical integration. At that point in time, we had no software that could work, but you could still program in everybody's software. There was no Y2K yet, no big ERP. And so people had programmers. We built the first version of R+ and DBR+ in Ditch Witch. We built the second version at Roseburg for R+, but we tried to use a software that was a TOC software. It didn't follow our theory the way we teach it. So we started coding in 2005. And Todd, raise your hand. Very first implementation of DBR+ ever, sitting right there, okay? R+ was still in a spreadsheet, and it took us until 2012 to pry that spreadsheet out of Todd and Ben's hands and actually get them into R+. So what you're looking at is Romac. And that was their very first iteration. And I think you have grown since 2005. What's your growth rate? Hundreds of percentage, multiples. And they came out of 2010. And because they've done the right things about right sizing their inventory and not getting rid of scarce resources, they were able to gear their supply chain back up. They drove their buffers down and they drove them back up when supply came back. They bought their largest competitor in North America. So just taking you through a little story. This is our very first Laterno Technologies. That's a jackup rig. We were the first people to put in project management tied to DBR, tied to R+. Please look at those results. The bottom one is 6x revenue growth with an inventory increase of 0.8x. Okay, that company was sold for 25 times what it was purchased for 8 years earlier by Rowan. Okay, and this is where we really started R+, DBR+, and Concerto together. And what we were able to do is Katrina came through in 2007 and knocked out 6 rigs. Rowan owned the rigs. They built the rigs. Those rigs that sank, several people lost their lives. So they changed, the Coast Guard changed all the safety protocols. To build a first-in-class rig, fastest they'd ever done it before was 26 months. We got the first one out in about 24 months. And then we started turning them out, building them in sequence, staggering them by 2 months. The best we ever got down to was 12 months for a drilling rig. And that was pretty amazing. They make $1 million a week. They're rentals. They go drill and then they bring in the pumping equipment. They're 95%, that fleet was 95% rented around the world. So that change in bringing a rig from 27 months to 14 months was a ton of money for Rowan. Okay. In 2011, I think that's when we got together, Eric. Okay. We had started working with Unilever, and that's where we learned about prioritized share. We'd never been in distribution. I'm going to say personal care products was not our strong suit. We are deep manufacturing based. But if you look at my clients, I have people like stem cell, people who make medical wire that roto-roots out your arteries. I mean, everything is different. There's nothing normal or the same about the industries, but they all have the same sort of results. What we learned at Unilever was that if you could figure out, it didn't matter if you had this distribution, that distribution, that distribution. The service centers that they marketed to had very different populations. So you'd have very large distribution centers and small distribution centers. If you look at any ERP system, the way that they choose to decide what's going to go to who is by who has the least cost transportation. That's important, right? And who has the least cost handling of material. What you want to do is make certain that every single distribution center has at least the same amount of share of the buffer. So if I only have enough to take everybody to 60% of the yellow zone, they all go to 60% of the yellow zone. Because what's the goal? No stock out, right? So that was where the distribution model that you're seeing was done. These are some books, and Chad's and Carol, I think we started DDI in 2014, Chad? Okay. And anyway, we decided we needed to make a market because if you have this great mousetrap, and there was no market. So the whole reason for DDI was to teach the world everything we know. Make it transparent. Goldratt said to me one time, Ellie said, Debra, tell everything, put everything you know, put it all out there, and they'll have to call you because they won't be able to do it. So just tell them everything and it won't matter. I thought, okay, so that's basically what we've done. And I know, David, you're laughing, and I told you, what'd you say? I told you like 6 years ago, there will be 100 software companies that have DDMRP, but nobody has the secret sauce, and that's DBR. So these are the kinds of companies we've been working with, and this is kind of dated. I haven't updated it, but what I want you to see is there's nothing in common with any of them. And I'm going to jump back here to Chad's slides. And since he already brought you up to here, this is what I'm talking about. This is the engine to get you to DDAE2. I have no patience, so I never do DDMRP by itself. I think it's a waste of time to do it by itself in a manufacturing company, because if I get the signal, all I'm going to get is a bang for the buck on my purchase parts. My make parts will not be sized correctly until I am able to schedule and know my leverage points. So I'm going to have to redo it anyway. So we run them in parallel. We'll bring up R+, IF demand scheduling or planning, and we'll bring up DBR within 2 weeks if we can get there. It usually takes a little bit longer because we have to totally redo everything that it has to do with routings, because everybody routes for cost. They do not route to schedule. And Todd can tell you a story about that. So long story short, what I'm focused on here is a DDOM. And that means different things to different industries. I'm not going to spend any time on this. Chad and Eric have already talked to you about that. So we're just going to jump right in. And I want to talk to you about 4 different, very different kinds of supply chains. So what I have down here is I have purchase components and I have an assemble to order. Okay. But what I'm able to do by having that in that format, I'm able to add a component buffer here. And what I'm getting then is lead time compression. I'm making that short independent planning horizon. Everybody understands that from the idea of DDMRP. But what you really need to understand, and where the bang for the buck truly is in your manufacturing. Because where's the only place that you can control your variation? Can you do anything about your vendors? Say no. No, you can't. But you are your own vendor, and the more vertically integrated you are, that's why at Laterno, that's why at Ditch Witch, we could get such huge gains. At Roseburg, they owned their forests. They made every kind of wood product you can imagine and shipped to distribution centers. Okay. This is an assemble to order. And this is an ETO. Most of my clients are a function of the top 3. They do all 3. Todd, you guys do all 3. In fact, you also do ETO. Okay. Haven't got to you yet, but I'm going to get to you about these things. Okay. This is the most complex environment in the world because I'm always looking for the long lead chain of events. I'm going to say that again. I'm always looking for the long lead chain of events. And I am always, when I go to eat a supply chain, you start at the beginning and you start at the end. Okay. Get a hold of the beginning and the end, and then look for whatever it is that is the drum, the constraint, the bottleneck of that supply chain. And you start there. At Laterno, it was the steel mill. Everything you steel, 5 different types of products. Okay. So let's do a little deep dive and talk about what this means. When we work with a company, the very first thing we do is we put together what we call a demand-driven design workshop. We are building your model. So we actually build the model in R plus IF planning, DBR plus planning, scheduling, and execution before we ever walk into the company. It takes us anywhere from 4 to 6 weeks. And we also create a flow. The other thing we do is we ask everybody to fill out a questionnaire of just 5 questions. Why do we do that? We are looking for the firefights. And what you'll see, and what I'm going to show you an example from KG, is when you know the firefights, you know the solution that you have to have. There's no point putting anything into an environment if it doesn't need a solution set. So I can have an engineering department that's a tweak, just does tweaks, does it very fast in the front end, no problems. I may not put in project management. But if I have a project management that is actually engineering is what is actually causing the variation to the rest of my supply chain, I'm late on the drawings, so I can't buy my long lead time parts. I'm late on the drawings, so operations is waiting for one critical part that they didn't get the drawing for. Those are what cause your variation. If you cannot block them, material availability will not do you any good. You don't have the drawings, you don't have the tooling, and you don't have the capacity. So we're looking for 4 things when we look for a world. Material availability, capacity tested demand, that capacity availability. But I also need the things that are critical. So if I have something that's tooling dependent, it has to be in my world. I'll actually put it into replenishment. I can take a replenishment model, take tooling, and actually make it have 3,000 parts if it has to be remodeled after 3,000 revs. I make that tool a child of the bill. Then every time it's taken out with that part concurrently, I get it down. When it gets down to the red zone, I know that that's a signal to tooling to go out and do that. You must connect visibility across all handoffs. Does that make sense to everybody? So the best design, the design is what's critical. If your design is crappy, your software won't help you at all. Okay? So we start with that design. The point of that design is to put everybody in a room from quote to cash, show them they have the same problems, and get them to agree on what the solution set is. What's the core problem? Then the second phase is out of this comes a project map. Second phase is we implement the map. Now all we are is at go live. Okay. At go live, we then have to learn how to drive the airplane. And when Chad was talking about those tactical tools of reconciliation, that's what I'm going to talk to you about also. You get to DDAE1 at 3 to 5 months. When you have a stable system, when the system is no longer bimodal buffers in your time zones or in your stock or in your sprint, that tells you you're stable. Usually we can get around 90 to 95% on time at that point, but we haven't got the bang for the buck. And the bang for the buck comes in being able to do flow metrics and trending. In that first 3 to 5 months, we just get the garbage out. The trends are not any good. Then we start building the trending, and that's where your tactical reconciliation comes in. And we'll show you what that means. At the end of when we're stable, then we do an audit. And the audit basically says, here's what we see in your world, and this is where your improvements are coming. So we get the trended data that we have, and we know what we have to tackle. You don't cross-train everywhere. You cross-train where you need the sprint, okay? You don't invest in anything except what's needed. And that's why focused investment is leverage. So this tactical reconciliation is the key. Once we have that, we implement that project map. And the objective is at the top of this project map is that you have a team capable of tactical reconciliation. Now you have a process improvement loop, feedback loop that is good to go for as long as you don't run off the rails. So one of the things that's great about cloud software is I can sneak around and see you all the time. We audit our clients when they get themselves in trouble. Had a lot of people come back to us after COVID, re-rev the supply chain back up. You get a change in your market. You decide you want to add some equipment. All those things change you. This is to get to DDAE2 status is anywhere from 12 to 18 months. So when Chad's talking to you about have the stamina to stay, it really means get a win early. Get a win early and teach people about the metrics, because if you don't change the metrics, you will die. So this is what we do in the first design workshop. Okay. So at the end of 4 days, we can walk in, and at the end of 4 days, we can have a model for planning, a model for scheduling, and a model for project management. 3 implementation maps. And the 4th day, we sit everybody down and we kick it off. So those project maps are very detailed. We know 80% of everything that has to happen for every implementation. It's the same for everybody. But at least 20% and sometimes a little bit more is unique to the company. I always learn something we usually learn something from every client, but every client has things that are unique to them that have to be in the visibility of the information they need. And that's the cool thing about the software, is that it is so flexible. The bad thing about the software is so flexible. So if you have a really bad model, good luck. The thing that's the problem with advanced planning systems is they are infinite capacity schedulers. Everybody know what that means? That's garbage. They also can be total finite capacity schedulers everywhere. That's total garbage. Makes it very nervous. So it's getting the right model. The very first thing we do is make certain that everybody understands the importance of flow. In that workshop, if they don't come out checking all these boxes, we did not accomplish the project. The second thing, they have to agree on what blocks flow. They need to know the right rules, and those rules are complex adaptive system rules. And the only reason I wrote that book is because I did a complete U-shaped break in my sacrum and I couldn't move for 8 weeks. I was flat on my back, and Chad said, well, now you have time, you should write that book. Yeah. I Googled complexity, and for the very first time, complex adaptive systems showed up. And it was only written about in biology. So I read John Holland's book that's Boundaries and Signals, and took that and translated it into supply chain. So I had to read it a couple of times. The purpose and role of control points, everybody needs to know what they are, and they need to understand that we decouple with time. I don't care if it's strategic stock, it's my vendor stored time. If I am doing time buffers, they're inserted into the routing. Take out all the queue time. Use it strategically, put it where it matters. And the third type is sprint. That is the capacity that you have over the drum or the control point that is your scheduling point for all your other resources, and it's critical. You don't lean it out. It's there to deal with variation. So that's the reason why lean never put anything to the bottom line. Variation exists. If you don't get rid of the variation, you cannot lean out. If you make everybody have the same capacity, all the variation hits you everywhere. Okay. Then you create a demand-driven operating model. We show them, we take their data, we show them what it looks like, telling them, this is your data. If your data is wrong, you can't trust this model. We can't just turn it on. But this is what it would do with your stuff. We show you where your drums are. We've already put in the control points and their buffers. And we can show you what demand graphs look like. Adults don't learn in theory. Kids do. Kids are curious. Adults have to have a reason to learn something. They're really hard to deal with. They only learn with something that's meaningful to them. So when we came up with using this model, it's because I can walk in and in 4 days, I have your attention because it's real to you. You can see it. And we can pretty much guarantee that the snapshot we take of your inventory compared to what it would be on our Smart Buffer Profiler and our replenishment is the dollar value we can guarantee you the project will sustain over the time frame it takes to drain that inventory out. So it is always an ROI positive within the first 6 months, just on the inventory alone. But you don't do it to reduce the inventory. You do it to get material availability so that you can get the things that need to go in the right priority onto that scarce capacity so you can ship to your customer. Okay, so that's the story. Then the second thing we do is we make certain that we ask them, what's gonna happen if we put this in? What bad things are in your world? What work practices, what metrics, and what thinking have you got to change in the organization? That goes onto the map and that becomes part of our education plan, okay? We know what it's going to be. It's the same everywhere. You cannot use efficiencies. And I'll tell you an ugly story about that a little bit later, okay? So we create that map. And this is a quick summary of what it looked like for KG. So we asked them, this was their problems, lots of problems, late, best case about 60% on time. This is their world. They have shared resources in engineering and operations. They have common vendors and common materials. Very difficult if you get out of priority. 13-layer bills, deep bills. Some of these projects take 2 years. Some of these projects take 3 weeks. Okay. They build products that have a 20-year life. And that means their service and repair industry is where all the margins are. 50% of their revenue will be service, high margin service and repair. That is a specialty that we're really good at. I live in a rig down business, airplane down, ship down, power plant down. Those things make people money. Make sense to everybody? I'm going to tell you their ROI, even that late, is in the 20s. Okay. Would everybody here be really happy if their ROI was in the mid-20s? They're not happy. Okay. And they shouldn't be. There's a lot left on the table. So this is what they have problems with. That's their reality. So we took, actually it's 41 leaders. I thought I changed this. And only 11 answers. Jay-Z's was 60 and 15. Yes. So this is, what do you spend your time firefighting? This is all wasted time. This is working outside the system. This is things I'm forced to do because I have to ship a project on time or I have to ship a product on time. And that means that we have in this environment an on-time to project or an on-time delivery measure. Everybody have some sort of flow measure in their world? But they also have an efficiency measure that they're working around. So here is the core problem, and this is the core problem in every company that I walk into. And it's because they live in traditional MRP and traditional ERP and APS systems. That makes sense? It's all I can see. This is what people would rather be doing. There's my 41. And I can't spend my time doing this when I'm spending all my time doing the other one. So what does that look like? This is where the solution direction lies. You want people working on the side where we have stable schedules, where we're constantly improving ourselves, where we can trust our management to make the right decision because they know the right answers. So this becomes the top of our map. This is where we're going. This is where people stay stuck. This is called a conflict cloud, and they don't have a laser pointer. And if I did, I'm gonna walk away for a minute. So I can maximize market ROI potential. This is something we want to do. In order to do this, I must protect each resource, product, project's deliverable. Every single project and every single product must ship on time. And in order to do that, my current system forces me to firefight everywhere. Does that make sense? On this side, in order to maximize market ROI potential, I must protect the system's limited resources. Why? Because it's basic factory physics. And in order to do this, because it governs flow of the entire system, I need to be living here. I need a system that prioritizes strategic projects and proactively manages flow at the company and system level that I can see from anywhere in the organization. So the only way to get that is to move here. That means if you have this system, your firefights go away. So that becomes the top of our project map. And Chad's already talked to you about this. This is that ugly supply chain bullwhip effect. This is the enemy. This is the core problem. If that's the core problem, I'm going backwards. How'd that happen? So the only way to solve a symptom is to get rid of the core problem. If you try and work at the symptom level, are you ever going to solve anything? It's never going to happen. So Chad did a version of this, and I've been playing with it for a long time. And the reason I'm playing over here is on one side, we have MRP and DDMRP, but on the other side, we have where everything really is happening. We schedule our resources as if they have infinite capacity, not on critical resource capacity. And when we do this, all kinds of bad things happen. Now that's a big, long arrow, okay? But what I want to show you is that our scheduling for MTS, ATO, MTO, and ETO never properly synchronize. And that's, even if I put in DDMRP, that is going to happen to me. And the deeper the bill is, the worse it is. So I'm over here on MRP, and we know that we've got all those procurement times are longer than tolerance times. So we use forecasts and planning bombs. And when we do that, we have signals with known errors. So adjustments occur, and when that happens, I have to stop what I'm doing, building to forecast, and do something different. And we can solve that, we know how. And I'm just going to zip along here. What I want you to see is right here. If I'm doing bombs flattened, I have oversimplified signals. If I have oversimplified signals, I'm going to trigger things to be done early. Whenever I trigger early, I end up with more WIP. Does that make sense? If everything starts early, everything is WIP. And that's mostly every manufacturing company that I walk into today. Same thing happens with engineering. So I'm just going to zip along here. And what I want you to see is when that happens, we send bad signals about the make to order stuff. And then we get this big loop coming back and it gooses this. And then it goes up and we just keep making a loop of bad things. This is that interdependence. It's a flywheel. And the more this thing turns, the worse the effect is. Okay? So let's just take a quick deep dive on engineering symptoms. So let's just say that if you have an engineering world, you're used to seeing things as a critical path. Anybody here ever work with Microsoft Project? Okay, critical path is one project. What happens when you have a critical chain is that if you are late on one of those paths, then it pushes other things out and your critical path will jump. And it will jump to the critical chain. The minute I have multiple projects, I have multiple critical paths and critical chains jumping. And when we do that, all these ugly things happen. So what happens is people pad their task times. If you ask a resource, how long is it going to take? They tell you a week when they could do it in 4 hours. But why do they tell you a week? Because they have all kinds of competing needs. And they know that they're never going to get to sit down and finish something. If you waste your safety by padding every task, then you're ignoring the leverage point phenomena. Okay? every time you have a delay that's expected and things work at different rates and you have efficiency metrics, do you want anybody like an engineer or a machinist to not have work? No. So what do? Release more work to keep them busy. So when the right thing comes, everybody's busy. And that means they're not available. So they put it aside, and then you have start and stop. And that start and stop starts making all of those critical dependency paths shift. It happens in manufacturing, it happens in engineering. And that's why people waste so much time putting things aside, doing expedites, breaking into setups. Is that sounding familiar? Okay. If you lose time at the critical resource, you will never regain it. If you lose time at a sprint resource, you lose the ability to recover from variation. Both those things kill you. So this is what we're going for. We're going to have to solve all of those issues. And the only way you can do that is to be certain that you schedule everything from critical resource finite capacity. Oh, I hate that. I don't know why I did that. Okay. So let's just say that our critical engineering milestone handoffs are missed. And over here, operations and engineering interdependencies are not accounted for in our planning. When we do engineering, we just say, okay, here's your tasks, go do them. We don't really schedule them. Engineers aren't used to being scheduled. This is the toughest thing to get over, is getting engineers to understand they can be scheduled. You can make a template routing just like you can from manufacturing. And in fact, it's much simpler and much easier to do that. If you don't account for the critical resource and schedule by it and protect it, and you don't know the dependencies, which means you can't schedule by it, then you have all of these missing task dependencies. So when something happens that you didn't plan for, everything starts jumping. Okay? Same thing in manufacturing. If you pad tasks everywhere, then you don't account for uncertainty where it needs to be accounted for. So resources begin working on what's available. So WIP goes up. Okay. Engineering misses those handoffs, so you start tasks as early as possible. WIP goes up. Some material buys are late, so we put things out there we can work on rather than the right thing. You're starting to see why WIP is such a mess. And this is just resources are busy now. Everybody's got something to work on. Start, stop, multitask. Time lost at sprint capacity erodes. That means I can't recover from variation. Time lost at the constraint erodes and flow decreases. The entire system flow decreases. Continually reschedule. We miss the operation milestones. Warranty costs go up, overtime goes up, rework goes up, and that means that we are back to messing the system up again and expediting again. And then material costs go up because we had to use stuff up. And what I want you to see is all of these things do what to ROI? Send it the right way or the wrong way? Yep. So there's a big opportunity. These are the things we must stop. So our solution set has to cover those 4 things. Does that make sense? So once you get people to say, oh yeah, that is us and that is what we do, and I understand why my solution set has to include these, then we can start selling the solution. So I came up with this equation when I was laying there, and everybody knows this. And I started thinking, why are we successful? Why does what we do work? And I read the Signals and Boundaries book, and it was like, oh my God, we've been talking about visibility forever, but visibility to relevant information is all our software provides. That's all it does, if it's modeled correctly. If I have the right information, we don't have to tell people the right thing to do. They know the right thing to do if they can see it. Okay. So that's, Chad's already talked about this, but it's variation to plan. What did I plan? What did I get? That's what I'm looking at. So it's all about system flow. And when I talk about smart metrics, I'm talking about on time, on quantity, on spec. Forget anything else. So Complex adaptive system rules are pretty clear. There's only 5 of them. The method to understand the system, a nonlinear system, is to map the dependencies. You're a social organization, you're nonlinear. You cannot be optimized. Nonlinear system rate is the dynamic predictions change. The short independent planning horizons is critical. And I get that by these and time inserted into a routing. So if I cannot protect myself with stock, I have to protect myself with sprint and with time buffers. Does that make sense to everybody? Because what I'm stopping is variation. Keep building on dependent events. I get to a dependent event just like stock, but with engineering operations hands off, it has to be time. Does that make sense to everybody? And the more sprint I have around my critical resource that I can use, the faster I can recover when something goes wrong and keep it from hitting that critical resource. Okay. These decoupling points are both stock and time and sprint, all 3 things. When I'm dealing inside my own supply chain, I can start talking about these control points. And it's simply a place where I want visibility to be known. I want to know if I'm on time or not. That's what a time buffer does. So a control point is someplace we grab a hold of it, we put a time buffer on it, and we watch it to know if is it coming to me? Are you on time? A drum is just a special case that we use to schedule, but it's still just a control point, a scheduling control point. And then we use Paretian statistics. We use these to execute. Green, yellow, red, I am not late as long as I get in the red zone. I don't take an action to expedite. As long as I'm going to come in that red zone, I'm good enough. Okay. What I'm really doing with those buffers is making sure my critical resource never starves. If I'm flooding it, then I choke because I don't want extra WIP on the floor. Cool thing about nonlinear systems is they cannot be optimized, but they can get smart. They can emerge to a higher order. So by trending these tails, we use these. This is what's coming to me as a control point. This is what the control point has to work on. This tells me the state of the system feeding me. This tells me the state of my control point. If this is building and I have a lot of lates, something's wrong with it. That makes sense to everybody? Okay. By trending those, I do what Chad's talking about. I am able to show the top how things work. And the cool thing about having things online is I can be anywhere in the world and drill down and know exactly what work order is blocking what project and blocking who's on time and who's not. And I'm not going to do this because you guys all know this. Chad talked about that. What I'm going to do is I'm going to show you an example. So this is Glitch. And this is what we do. We map the dependencies. So I'm looking at different flow lines. Then what we do is we put in the stock buffers. So we were able to put in some stock buffers here and stock buffers here. Not a lot you can do with ETO. Random packing hardware already had a stock buffer. Then we choose the drums and the control points. Entries and exits to the system are always control points. And then we pick a few drums. This lives by itself. It has its own drum. Actually, there's a drum there too. That lives by itself. But the big deal is welding. Everything gets welded. All of this is upfront different kinds of flow lines, cutting, machining. Okay, so this is their original. And then we put buffers. We fix it all with buffers. These are sprint capacity. Anything that doesn't have a drum has sprint capacity. Okay. Intuiflow, R+, DBR+, talk to each other. And in DBR, the first shot at the drum is based on the priority of if I have a buffered part, if I'm stocked out, I have the highest priority of all. Okay. If I'm a non-buffered part, it is your ideal start date in the past? If you're in the past, I'm already burning my buffers. Does that make sense? That's days late. But notice this protects many things. So stock buffered parts have a higher priority than a make to order one order. Make sense to everybody? So that priority of that work order is what determines who gets the first shot at the drum. Okay. We leave priority 1s and 2s. 2 is for the scheduler, and 1 is for, we say, the supreme buffer commander, or known as God with a small g. That means that's an executive decision that I'm going to move something ahead of something else. Priority 1 is reserved for that executive decision I just talked about. So what we get, this is a picture of the scheduler, sorted by release date, sorted by priority. Now notice I have a bunch of those with stockouts with demand. Okay. This is a schedule of the drum. You can see that it's level loaded. The drum derives all things that feed it and all things it feeds. So that is a schedule based on that drum. It will either come in this order based on that drum, or this is what I need this to do in order to feed that drum schedule. Does that make sense to everybody? If you see red, it's a backlog. If you have a backlog, you choke until that backlog's gone on that drum. Or you work overtime, or you find a way to offload. Okay. You don't just keep dumping things into the system. So very first thing we said we'd do is we said we would schedule at infinite capacity or finite capacity. Make sense to everybody? Have total transparency across the organization. Oh, one backup. So this is an example of that buffer. This is late. This is what's coming to me. This tells me the state of all the things that feed me. This tells me the state of my critical resource, my control point or my drum. This is an example of why we start as late as possible. All of the thinking in DBR is go to the end date and start everything as late as possible. These are children that need to happen. These are different work orders or different drawing packages. I could make this an example of a project, or I could make this an example of a BOM. Does that make sense to everybody? So that is the BOM, and these are the lead times. So that is the routed lead time. And if I want to hit that date, it's very clear that this is the critical leg. Does that make sense to everybody? So I am scheduling all the children to arrive at the right time to feed the right place at the critical leg. If I start over here, what does that do to me? Jams me up at the front of all those flow lines. So just answering the questions about what does it do for us? Look at all the things that happen. We get synchronization. The most important thing is material planning, full kit handoff, which is drawing to planning. All of those things are synchronized if I start at the back and move schedule backwards. Okay. I get staggered releases. Staggering releases takes the load off of resources, and it's very easy to find your drum. In a world where you start there, everything's a drum. Everything looks like a bottleneck. So this is the packet builder inside DBR. We came up with this a long time ago, and this is the way to keep children organized to their parent date. So what you'll see is a packet long leg. So there's the child that has to be released first. What I want you to see is that its end date feed its parent's start date. Make sense? Every single one of these, end date feeds parent start date. Okay. If any one of them slips, they all slip together, because I can't put it together if I'm missing one of the parts. So there's no point in wasting the capacity. Does everybody understand? Okay. So that is what it looks like if I were to bring it out into the dates. Children matched up with children to parents in levels. So DBR S&E moves the packet forward or backward. Think of it as kind of like Legos in a box coming back and forth together. They inherit, every one of those work orders will inherit the priority of the highest priority work order in the packet. I want to keep them together. Okay. So this is what we did at JZ. And what you're seeing here is engineering handing off to planning and ERP. So up until that point, I don't have a BOM. Okay. Then I make a purchase order and a work order, and DBR can schedule a prototype. Then I can start that prototype, and then after it's done, I hand it back off to engineering. Then we build the real bombs and routings and say, hey, you can build the whole thing. Hand off to operations and planning. Buy the parts, purchase orders and work orders. POs go to the vendors, work orders come into DBR. So this is just a different way of looking at a diagram. And what I'm pointing out to you is a network can be a BOM, it can be a routing. It is all the same thing. If you take a BOM this way and turn it on its side, it's now a routing. Yes? Okay. Now here's what we discovered at the first audit. So basically at the end of the workshop, that's the ending of a workshop. We've got our project plans. They look like this. We can usually get this up in 3 to 4 months. This staggers by 2 weeks. This comes up as soon as we can get it. Depends on how deep the networks are. So this is what we did with KG. I want you to see this. 14 months ago, they went full live. OTP for aftermarket hadn't changed, 98%. That's their bread and butter. They sacrificed everything to get there. But when we started with them, everything else was 65%. Today, as of the end of April, they were at 95%. They had a backlog of projects of 12.5 weeks. Today, it's 0. At the end of March, it was 1.5 weeks. During that time frame, they did all that. Their sales grew 20%. Inventory turns. Remember, this is E to order. They would have been happy with 2. Okay, 1.3 to 3.7, and this month they expect to be at 3.9. Every single month better. That's a 3 times. This is velocity. Does everybody understand why I'm saying that? It's velocity. Material availability. Stockouts are less than 3%. That's for both make components and for purchase parts. WIP reduction, 40%. This 40% means that velocity. Why do I say that? If my make to order time frame is this long, how big does the component buffer have to be? This long. If my cycle time becomes this, every single component buffer or finished good buffer goes down. This is where the gold is. So this is the major lesson that we learned in the sales and scheduling execution was our big problem was here. This handoff was terrible. Everything else is in IF, so we couldn't see the flow. So Concerto isn't integrated and there's nothing in the ERP system because it's not there yet. So I've been playing with something. And so we started NOV. We've done 2 workshops for NOV, Hydro Rig and Texas Oil Tool are both done now. And what I've done is instead of using Concerto, I'm using IF. And why can I do that? Because IF has locations. So let me show you what that looks like. Think of it, this is, what's the way to say this? This is the handoff between the systems. So in here, if I'm in a software that's separate, I have a handoff here at planning. Concerto follows the old TOC rule of all the buffers at the back. Okay. We gave that up in the 90s. I didn't like that in 95, and we came up with the idea of independent planning horizons have to have their own little buffers at the control points. That's why they exist. Control points create independent planning buffers. Does that make sense to everybody? That's an independent horizon. So what we're able to do is this handoff, if I could make it visible with a buffer in front of it like this, this is our design we want, then I could actually control engineering and see it and connect it to the long lead time part. And if I drive backwards into engineering, and instead of doing just 2 handoffs for mechanical and electrical, I divide mechanical and electrical into lead time part categories, and we came up with 7, then what I can do is deliver the long lead time part drawings first. If I do that, I get a huge compression here in being able to get those parts in. Does that make sense to everybody? So it's always about the long lead time part here, 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 but it has to be connected. And that's what we were missing. We were missing that ability to have R+ talk directly. And so I came up with the idea of let's put the drawing as a child of the part. And now I can put it in replenishment. Now it has to be fed by Excel, and that's great because now I don't have to talk to the ERP system, so I have no interface I have to do. I can make a DBR that's just networks with resources that are engineering resources. So we built this model and it looks like that. And we will be piloting the very first one of these. And this is what it will look like. R plus will give us our IF. I'm getting there, Eric. Slowly. I did switch out the slides though. Yeah. What we're getting at is that gives us the first shot at the engineering drum. Okay. That gives me the loading for that drum. We feed back this date to R plus saying, hey, expect it here. So it's no different than a vendor saying, here's your expected lead time. Then that says to DBR, well, actually, now let's say I've had the handoff and I actually have the BOM created. R plus creates the work orders and the purchase orders. DBR loads that and sends it back to R plus and said, hey, expect your make parts here, keeping everything synced. I have total visibility to my system loads, just like I do in engineering. Everybody has a dispatch list. This is real-time execution. Feeding my buffers. All resources are synchronized to the time of the parent part, start date, because I've got packet scheduling. Same thing with the drawing, packet scheduled. Buffers are protecting those, giving early warnings. Yep. I can, because the other cool thing, because we use, when you do critical chain project management, you don't just do the engineering, you also do the purchase lead time parts and the drum. So what we do is we take the product or the project that most looks like it, we call a go-by project, and we make a skeleton of the fab. It can be 8 weeks, yep. And all we do is put the drum in like we would in APM and say, you know, the welding is what really counts. So how many hours of welding is that going to be? Okay. And then we use a order max on it. So we get it broken into work orders so we can get it staggered. So that's, we can commit. Right now at KG, they can commit because they're ahead. This system, I think, will be able to commit right away. Okay. But it also will depend on how big that backlog is and you have to work through it. Right. Okay. So here is coming down to my dashboard for my executives. And this simply sums up all of the project buffers, but I can drill down to any of them. And it's one of the things that I love about IF is that I can make a location for manufacturing. I can make a location for engineering. And because I can connect them through R plus, I have a fully connected system for the very first time ever. And I've been at this for 20 some years.